love of life, and the fear of death, are the two main reasons that drive the search for immortality for humanity. Numerous generations have tried to understand the secret to long life, by implication, immortality since time immemorial. Ancient alchemists were fascinated with the elixir of life being discovered. In the 16th century, the Spanish explorer Ponce de León set out to Florida to find the youth fountain. Significant developments in science and technology have allowed scientists to understand life at its heart, cellular, and genetic levels rapidly moving forward. As a result, life expectancy has progressed gradually, suggesting that technological interventions are capable of prolonging human life significantly. One central question emerges as science seeks to unravel the complexities of human life. Will we get to a point where our knowledge of science proffers us a key to living forever? Futurists made several predictions in this line. Although this may sound like an over-ambitious venture, we see promising results from current life extension research projects more than ever. If things proceed on the same course, it's been predicted that 2050, the next 30 years, will be the benchmark for when we will reach immortality. Sounds fascinating, right? That's it. Here are the 10 ways humans will become immortal in future. So let's start. Cloning organs. An alternative to printing organs is cloning. The idea here is to make new parts of your body develop. Cloning is not modern technology. In the past, scientists cloned ears, bones, and skin. The aim is to perfect the cloning of more complex organs permanently as a method for life extension. Longevity pills. In the consumer markets, the first pills which activate the anti-aging enzymes have made their way. In the coming years, these pills are expected to extend human life by 50% and more. A pharmaceutical firm called Elysium Manufacturers are one example of these tablets. The mystical pill of Elysium is based on supplementation with NAD+, a compound that has been shown to slow down aging. Cryonics. For a while now, cryonic technologies has been around. It includes freezing people with temperatures so cold that for decades or centuries. The process would preserve human bodies beyond the benefit of today's medicine before future medicals return the person to full health. The body is put in an ice water bath first. Chemicals immune to ice are pumped in, taking the water's position. In the next step, it hardens without forming cell-damaging ice when the body is cooled using liquid nitrogen. Cryonic technology is fueled by the expectation that in the next decade or so, medicine will improve. The people who are cryogenically frozen will be brought back to life and cured of their health issues. At this point, the scientific treatments available will allow the individual to live indefinitely. In the most literal sense, cryonics is a wild experiment, but companies like Alcor and the Institute of Cryonics provide chronic services for a fee. The first person back in the late 1960s to be frozen was Dr. James Bedford. More than 300 individuals have been cryogenically preserved since then, pending resuscitation, to be deanimated when the time comes. Another 3,000 people worldwide are currently on the waiting list. Regenerative blood transfusion. Regenerative blood transfusion is the most bizarre and divisive interference by far. Get this, so that older people can reverse aging by fusing themselves with plasma from young people. The idea is that something could assist an aging adult get healthier inside a young healthy person. As early as the 1950s, a weird technique called parabiosis checked this theory. Parabiosis involves sewing the tissues or two mice together to determine if one animal's circulatory system has compromised the other. The primary aim was to decide whether to younger blood, the older animal could live longer. Since then, researchers have tried to grasp this experiment's feasibility. Several studies have shown that young blood can reverse age-related impairments, but this is yet to be proven. Young blood has been shown to contain GDF11 and anti-aging protein levels. They progressively lose this protein as people age. At the moment, a startup called Ambrosia provides significant infusions of the highly desirable young plasma. The FDA, however, stepped in to caution individuals about this technique, citing allegations that the long-term benefits of the treatment have yet to be confirmed. Gene therapy. For all biological processes, the genome is the instructional manual. Anything that happens is regulated by gene expression in our bodies. The heart of genetic longevity therapy is telomeres. At the end of the chromosome, telomeres are repeated nucleotide sequences preventing it from degradation or fusion with adjacent chromosomes. For each subsequent division of cells, telomeres progressively reduced. With every cell division, we lose about 50 to 400 base pairs. Cell division is halted at a particular stage to protect the cells from complete telomere destruction to retain the genetic material of the cell. In a stage called senescence, the cells join. You can't duplicate the senescent cells. Their aggregation is the hallmark of many chronic diseases and age-related degenerative diseases. In brief, the shorter your telomeres are over time, the older your body grows. Late in the 80s, an enzyme that lengthens telomeres called telomerase was described. Telomerase will add DNA back to telomeres, and the mortality enzymes has been dubbed. The bad news is that only embryonic cells and adult stem cells are involved in telomerase. The task was been to find a treatment that induces telomerase activity explicitly in adult somatic cells. UC Berkeley scientists managed to get a clear picture of the telomerase enzymes by cryo-electron microscopy in 2018. In a feat that took more than 30 years to attain, this marked a significant leap forward. As a consequence, we are closer to creating specific therapies targeting this enzyme, and we might say goodbye to some of the most critical causes of mortality soon. Diabetes, cardiovascular disease, and certain cancers. Nanotechnology. Artificial intelligence works with nanotechnology to overcome some of the most daunting problems facing our bodies. Infectious and related degenerative diseases. Nanotechnology utilizes tiny particles designed to perform a particular AI-controlled purpose. Like immune cells scouting for and restoring antibodies' physiological disruptions, the small nanobots travel around the body. The ongoing study focuses on wiping out cancer, Alzheimer's disease, obesity, and diabetes. Yet the future of nanotechnology will have more ambitious objectives. The complete realization of nanobots can remove biological disorder and aging. In 20 years of nanotech devices performing such functions for us, we'll see widespread use. We can conquer illness and age within 30 or 40 years, and nanobots will scan for and patch organs in cells that need repair, which would contribute to profound changes in our health and longevity. MIT researchers are now using nanobots to deliver killer genes that destroy cancer cells in the early stages. Existing in the cloud. We will upload our identities to cloud as if living in android bodies is not enough. We might end up living in a simulation of a machine. This sort of life implies that we'll get everything we want because imagination will feel any sensation. We can import our identities from the cloud into a robot body. There is a need to occupy the physical world. Use it for some time and upload it back to the cloud. Living in android bodies. Futurists have widely popularized the idea that we do not need a body to exist by trying to create a brain-computer interface to address the weaknesses of our physical bodies. This process will extend, if not forever, the human lifespan by hundreds of years. This plan appears to be the most optimistic, with estimates predicting that by 2040 would materialize. Elon Musk's continuous attempts to build a brain-computer interfaces through this Neuralink project has shown tremendous progress. Dmitry Eskov, the Russian tycoon, has also invested heavily in related causes. He launched the 2045 initiative in 2011. The project aimed at replacing human bodies with digital avatars, each fitted with the contents of the human brain, including consciousness. Just imagine this. Your body dies one day and your brain stops with it, but no big problem because 99% of your mind is still okay. Running on IT happily in the cloud. You link to an android to use as your body from now on. Attend your funeral and then carry on as before, always you but with a younger, highly improved body. Assuming you have saved enough and planned well. As mind-boggling as it sounds, it is a fact that thanks to projects like Neuralink, we are one click away from merging our brains with machines. Reversing aging. Over the past few decades, the field of longevity medicine has made huge strides. One of its most significant results is how rapidly humans mature. Epigenetic variables play a more critical role. Epigenetic factors are elements that affect gene expression beyond our DNA sequence. They include food, atmosphere, lifestyle, and our thoughts as well. Previously, we felt that the aging process had little to no influence over us. Aging, we thought, was solely genetic. Multiple research results have shattered this idea. Harvard University geneticist Dr. David Sinclair, one of the most prolific pioneers in longevity, has shown promising results as initial clinical trials. The anti-aging advantages of calorie restriction are the foundation of his work. Decades of studies have shown that scientifically reversing biological age, calorie restriction extends lifespan. Dr. Sinclair demonstrated that without the need for starvation, the molecule NAD could imitate the effects of calorie restriction, thereby prolonging human life. 3D printing new organs. Imagine that one day, due to chronic alcoholism and cigarette smoking, your liver and lungs threaten to bail out on you. You go to the hospital and doctors will create and 3D print the exact organs for you using cells from your body instead of long-term treatment. The organs are replaced by robotic surgery, and within days, with no risk of graft rejection or organ failure. For any vital organs, the procedure can be performed repeatedly, ensuring that they still stay young, healthy, and functional. That is what regenerative medicine promises to deliver, along with 3D printing of biological organs. Regenerative medicine utilizes stem cells to create new organs. Stem cells are primitive cells that in the body may give rise to any partition. They are present in embryonic cells, but most organs divide and lose the potential for regeneration as we mature. Adults themselves, however, are still present in the blood, bowels, skin, etc. Scientists to grow new organs from scratch by using stem cells and the right biological signals, and 3D printing is used to ensure that we reproduce the exact ultrastructural structure of the organ in question. Their bodies would not reject bioprinted organs created from cells of a person. They're not regarded as extraneous. The body will not therefore launch an immune response to them. Researchers from Israel 3D recently printed entire human heart from the patient's cells, hoping that the technology could replace diseased organs in the future. Biomaterials for 3D printing would also render organ donation. That's it for this video. Thanks for watching.